Okay, let's move to the worksheet number 8 from lecture number 8. So now lecture number 7, we discuss about the particle moving inside the magnetic field or current carrying wire inside the magnetic field. Uh, uh, they will get the force, that is the magnetic force, and we know how to calculate that, right? So now lecture 8, actually, we're going to talk about how to create the magnetic field. So creating magnetic field is the part that we're going to cover. So now, as soon as you know that creating magnetic field, definitely if you have magnet, I know how to create the magnetic field, right? If I have north and south magnet, so it will be going from north to south, right? So there is a magnetic field in between these two. So that is, we already know. In addition to that, there are current carrying wires that can create the magnetic field. So if I have a current going upward direction, this current carrying wire will create the magnetic field around the wire. So now if you use this right hand, we call as second right hand rule, as you can see on the right side. Thumb again to the current. Thumb in your right hand is current always. Your four finger tips will be the magnetic field direction. But here actually they are not keeping perpendicular. What we're going to do is pointing your thumb tip points to the direction of the current, and then you're going to grab the wire. When you grab the wire, this side magnetic field will be inward, but this side magnetic field will be outward. In front of you have magnetic field, right? And exactly opposite on the current direction has the magnetic field this way. So that means it will do this kind of magnetic field around the wire. So this magnetic field is depend on B equal mu naught I over 2 pi and distance from wire to point of interest. So now you see that when R is greater, since it is in the denominator, it's getting weaker and weaker when you go further away from the wire. Strongest closer to the wire, further away from the wire it is getting smaller, and on the wire there is no magnetic field either, right? So that will be how we're going to calculate the magnetic field from the wire. In addition to that, also we discuss it is also a wire, but your wire can have circular wires, right? This is a straight wire, first one. And second one, the wire piece I have here is arc shape. So in that case, if you have radius r, if you complete this circle, if you take the angle at the center, then this magnetic field will be equal to mu naught I, let's write pi instead theta, pi divided by 4 phi and r. That is the magnetic field at this point. Again, you're going to use your thumb to the direction of the current. That means this place I have outward magnetic field, right? So those are the things that we discuss in this chapter, and it can create a lot of problem by adding many straight wires. By adding circular wires, you will be able to create the magnetic field and calculate net magnetic field by using superposition principle. That means by using vectors, direction and magnitude. Okay. So now let's move into the question numbers. So let's move into the first question. So I have infinitely long straight wire in red on the diagram. Let me make this little greater in here. Oops. So you have a straight wire. It did not allow me to make it greater because I think I have picture inside. So that will not allow me to change. Let's keep as it is. Okay, so we have a straight wire as red and label the current as I1 in the diagram. and while loop of radius r as current I2 and I1 equal 4I2. The connection between these two are given. So now my question is, if the net magnetic field at the center, the circular loop is 0, how far is the center of the loop from the straight wire? That the y letter I have it in here, you need to find that y in terms of, there is no numbers, you can say in terms of r, we can say in terms of r, we need to find. If numbers given, you can plug it. Okay, so now here what I'm looking for, you understanding about the directional information and how you going to consider your superposition principle in here. So now I have current, let's take the straight wire. Straight wire can create the magnetic field at the center. The red wire will create the magnetic field at the center. What direction it will create? You're going to grab the wire. When you grab the wire, you have magnetic field at this point, outward direction. I'm going to say B1, outward direction. So we know how to calculate B1. B1 will be permeability mu naught and current of that wire and 2 phi and distance to the center that I label from the wire, that is the label in Y, right? That is B1. And what direction? Outward direction, it's right, outward. So now I have blue wire piece, that is a circular wire. So that will carry the current on clockwise direction, as you can. If you grab the wire, that will create a magnetic field inward direction at this point. Inward direction magnetic field from the blue wire is equal mu naught I2 and phi angle and divide by 4 phi and r according to the labeling. But this phi is for complete cycle. You know that complete cycle, this angle is 2 pi. Right? So because of that, I will be able to simplify this. Mu naught I 2 phi will cancel out, 2 phi will cancel out. I have 2 and r. Okay. So now after you know that B1 is outward, B2 is inward, whichever greater will be the direction of the magnetic field. So, but it says net magnetic field at the center is 0. That means if you write it in outward direction, that means B2 minus B1 is equal 0. That means B2 equal B1 according to the question. So now let's plug those in here. I2 divided by 2r should be equal to mu naught I1 divided by 2 phi and y. And then you see, as soon as mu naught will cancel out, these two going to be cancelled out, right? So now I have I2 and I1, that also I will be able to replace. You see, I1 is equal 4, I2 is given, right? So let's replace that in here and rewrite your equation. So we have I2 over R on the left side, and right side I have I1, that is 4 I2 over I and y. Then I2 will cancel out. Finally, I will be able to write y as a function of r. So do the cross multiplication in here, right? So then y, you can solve for the y, will be 4 r over y. Okay. So if numbers given, you will be able to calculate it. Since numbers are not there, you can just use, you can, if you want, you can simplify 4 over pi. Pi is 3.14, and it will be give me around 1.27 r. Okay. You can write it in terms of r. Okay, so now next question. In next question, you see that I have 3 straight wires, right? And according to the figure, the middle wire carries the current I to the left, as you can see, and bottom wire carry the current to the right, and top wire carry the current to the right. And all are the same current. If the wires are distance d apart, what is the magnitude of the magnetic field at P point? So now, where's the P point? P point seems to me in the middle of top and the middle wire. So let's say it is in, if not given. Okay, that is P point. Okay, so now I need to find the magnetic field at P point. I know that top wire, bottom wire, and middle wire all will create the magnetic field at P, right? Let's start from one of them. Let's start from the top wire. So now top wire, let's label it as 1, 2, 3 wires. So first wire will create a magnetic field around that wire. That means at P point, I have magnetic field inward direction, magnetic field inward direction. Number 1 will create the magnetic field inward direction at P, and how we calculate it? B, I'm going to write B1. Okay, B1 equal mu naught current I divided by 2 pi and distance from wire to the point of interest, that is D over 2. Okay, so this will be, see that 2 will cancel out, mu naught I divided by pi and D. So now let's go to the second one. Second wire will create the magnetic field, only we are looking for P point. So we'll create the magnetic field again inward because current is to the left in that case, inward, and B2 will be equal to mu naught I divided by again 2 pi D over 2, distance from green wire to the P, that is the D over 2, mu naught I over pi D. It seems to me both are the same. So now number 3 will create, current is to the right, then your magnetic field will be outward direction due to that at P, right? So now B3 will be mu naught, same current, and 2 phi. Now distance I need from this wire to this place is this whole distance. So that will be, this is D over 2, that will be 3, we write it in here, D over 2 plus D. So that will be 3D over 2, right? So 3D over 2. So now 2 to cancel out again. That will give me mu naught I 3 pi and D, right? So now we need to find the net magnetic field, right? B net, right? You see that I have 2 inward, 1 outward, right? So 2 inward, if you add them together, I know it is greater than the B3. If you don't know that, just leave it, select the direction according to that. I'm going to write it inward direction, right? Inward direction, I have B1 plus B2, same direction, but B3 is negative because it is outward. So now we're going to write, let's simplify first. I don't think there is numbers given, only thing we can give it the variables. So now we're going to add it, mu naught I over pi and D is common for all 3. First one I have just 1 plus 1 and next one 1 over 3rd, right? This will be 7 over 3. 3, 6, 7, yes, 7 over 3 mu naught I over pi and D. So that will be net magnetic field, direction is inward. Okay, so let me see. Oh no, I did the mistake in there. So this is negative, right? This part is negative, not plus. This is negative. This is negative means this number will be 6 minus 1. That means 5. 5. Okay, good. And let's move into the next question. Okay, let me try to enter from here because I need little space in there. So now I have this diagram, right? So now I need to find the magnetic field at point P. Point P is my point of interest, and current I1 and I2 is given and D is given. So now you see that I1 is current is going outward direction, this dot, and this current is inward direction. So I can switch those direction as I need to make a new question, right? Okay, so but according to this question, what I know is I1 current, right? Outward direction. This pre-body diagram is very important thing. You always need to draw for the vectors, right? So now I1, you know that the current direction is outward direction, then you point your thumb to the direction of current, then you are drawing your pre-body diagram only the point of interest. So that means at this point, your direction of the magnetic field is here. I'm going to label it as B1, right? And now I have the current carrying wire on the right side, inward direction, that will create the magnetic field on this direction at point of interest, B2, right? And in addition to that, you know that in geometry, since these two are equal, since this is 90 degrees, this will be 45 degrees. So that will be still 45 degrees because it is exactly same. It is better that you draw your x-axis and y-axis first at your point of interest. And this angle also theta, this angle also theta, this angle also. Everything is 45 degrees in here. So theta equal 45 degrees on this diagram, not always. Okay. So now I have B1 and B2. I know the direction in my diagram. Then my next part is calculating magnitude and the direction. So let's write first your B1 and B2. Okay, so my B1 is equal, due to straight wire, mu naught current I1 divided by 2 pi, and distance from your point of interest to the wire is R. And B2 will be mu naught I2 divided by 2 pi and again R. So D number is given. Now you need to get the connection. So D is given. How do you going to connect? How do you going to find R, right? So you see it in here, right? So you can use Pythagorean theorem, or you can just check your cosine and sine information, and you will be able to find it. You see that my hypotenuse is R, and I can find my adjacent, that means half of D, right? So that means D over 2 is equal to R times cosine of theta. So now R will be D over 2 and divide by the cosine of theta, that is 45 degrees. D over 2 cosine 45 will give you root 1 over root 2, and this will be equal to D over root 2 equal R. So now if you calculate the R, D over root 2, let me calculate it. 3.75 meters. 3.75 meters. So I need that number later on for the calculations. Okay, so now let's write this. Let's calculate B1 and B2, although I do not have the numbers in here. Yeah, let's, you can calculate since everything is given, or else we can calculate at the end. I think let's calculate it. Let's do the calculation here. So you know that the mu naught value, right? So mu naught value will be, check in your lecture. So mu naught will be 1.26 times 10 to the -6 Tesla over amps, and then I1 is 15 amps. You're going to divide by 2 pi, and R is 3.75. Okay. Next one will be again 1.26 times 10 to the negative 6 times I2 is 32. Going to divide by 2, 5, and the same 3.75. Okay, let's see that if I can calculate this number. And this number I get, do the calculation and let me know if it is incorrect. You can, I'm showing the process here. That's the important thing. -6 and unit of Tesla. And I get this number as 1.711 10 to the -6 Tesla. Okay. Now, we know that B1 and B2 need the direction, right? Maybe that's what my question pattern that I am asking. Maybe I will ask calculate B1, calculate B2. What is the direction of B1? What is the direction of B2? I'm going to answer this each part separately. Okay, so now you know the B1 and B2. Now next step is calculating the resultant vector. So as you remember that vector addition, first thing is if you realize one method, if you realize that B1 and B2, one method, easy method actually here, right? If you identify B1 and B2 are perpendicular to each other, then what do you know? You can use the Pythagorean theorem directly, right? You can directly use you're going to use directly Pythagorean theorem, and then you will be able to find the B as B1 squared plus B2 squared and square root of that. Since you have B1 and B2, you will be able to find the B from this, and then theta, you can find it by using tangent inverse of B1 divided by B2, but that angle, you make sure that you write with respect to your positive x-axis. That means definitely the angle you are getting here, you need to add 45 degrees to that to give it to the positive x-axis, because your resultant, whichever greater, you know that the definitely according to the number, you see that your B2 is greater. Because of that, your parallelogram going to complete somewhere here, right? So that angle you get from your B2, because of that, you need to do this arithmetic and calculate it. That is one method. That's the easiest method that you can do. But I'm going to use the traditional method. But this is what I recommend if you identify those are perpendicular. That is easy. But the other method, that traditional way that write in components, is the method that I'm going to do it here. You will get the same answer for the both, but this will take little time writing the components, right? So now as soon as you see that B1 and B2 are not in X direction, you definitely know you will be able to write your B1 X component and also B1 Y component. So B1 X component, you know, its B1 is 0.802 times 10 to the -6 x component in there, cosine 45. Since it is 45 degrees, it's cosine 45 or sine 45 will give you the same. Since it is negative, I'm going to write it as negative, right? B1y is 0.802. It's a positive number, 10 to the -6 and cosine 45, right? And similarly, you have B1 2x and B2y. So B2x is positive number, that is 1.711 times 10 to the -6 and cosine 45. And this will be 1.77. Y component of the second vector, 1.711 10 to the -6 cosine 45, right? They are the same direction, both are positive, right? So now if I want to calculate Bx, that will be from B1x plus B2x. You have the numbers, try to add them together, and you see that your B1x is a negative number. What I get is 0.64 2 times 10 to the negative 6. That's what I have for the bx, and by will be b1y plus b2y, and you're going to add them since both are positive. I have 1.776 times 10 to the negative 6 Tesla. So now, after you calculate bx and by, it is better that you draw the cartoon of your diagram, right? So this is your bx, this is your by, right? And definitely my by is greater. I know that this should be little greater than the other one. I'm going to extend it b, not 2y. b2 by is great. So now if you complete the parallelogram, this will be your result, and that we're going to calculate it as b. This is the angle that we're going to find it out, right? So now we're going to use the Pythagorean theorem. B equal bx squared plus by squared and square root of 2, and getting the square root. What I get is 1.89 times 10 to the 6 negative 6 Tesla. That is my net magnetic field. And now I need to find the direction. Direction will be tangent inverse by over bx, right? By over bx, by over bx, rewrite it, and by over bx, and then find the theta. I get around 70 degrees. Okay, so now theta with respect to positive x-axis is respect to x. With respect to use WRT positive x. So that will be the answer. That will be the same answer you are getting from this, probably 1 or 2 steps. Okay, but whichever way you decide, you can use it if it is correct, right? And so now we're going to move into the number 4. So let me probably enter from here. Okay, let's move into the number 4, and also we have 5 to do. Okay, number 4. So now in number 4, you can see I have 2 wires horizontally, current direction to the right, both wires. But it says a second parallel wire 20 centimeter below it must carry how much current I2 so that it doesn't fall due to gravity. You know that when I keep the I2 wire, this wire going to fall down because of the force of gravity. But there is a force created by top wire. Because of that, I need this I2 current wire to stay as equilibrium, right? So that's the force that I need to calculate and make it to equal to the force of gravity. Then it will be stay at equilibrium. Okay, so now question is finding I2, right? So now, although I have the diagram in there, we'll say there is no diagram. Diagram is not given, right? What I know is there is a force of gravity. We're going to draw the free body diagram on this wire. We have force of gravity that will be equal to mass of the wire and chi. And now top wire will carry the carry the current to the right. Then you use thumb, and then it will create the magnetic field on this wire everywhere inside. So that is the magnetic field from the wire number 1. And then you have current towards right direction. And now you see that current is right, and magnetic field, current carrying wire inside the magnetic field. Now you're going to use the lecture number 7 information. So now we have current to the right and magnetic field inward, and use it, and then your right hand, and then you will see magnetic force in this direction, right? So now to stay this at equilibrium, we know that net force towards y direction, I'm going to use the arrow this way, y direction should be equal to 0. Now y direction, I have magnetic force, negative y direction force of gravity should be equal to 0. What that means is force should be equal to the force of gravity, that will be equal to the m and g, and magnetic force we can write it as by using current of that wire and length of that wire. Length is given, right? Length of that wire, and then the magnetic field on that wire due to the wire number 1 and sine of 90 is just 1. I'm going to use that. And mg, what I need to find is I2. I2 will be mg divided by length and B1, right? So now it's very important. How do you know the B1? B1 I label from the top wire mu naught I1 over 2 phi and distance, you see that D, distance D, right? Let's plug that into here also, then we can calculate the number mg divided by L, and I have mu naught I1 on the denominator and 2 pi and D will go to the numerator. So now we can plug the values. Convert into SI units. M is 0.12 grams. 0.12 grams 10 to the negative 3 kilograms. And G value 9.80 and 2 and pi and D is 20 centimeter. No, D is 20 centimeters. That means you have 0.20 meters. You're going to divide that by the length. Length of the wire is 20 centimeters. Wire below, let me see. Okay, so length, you see that here, 20 gram per meter length. I can use it as 1 meter. If it is a 1 meter length, that will be the mass. Okay, 1 meter length, and mu naught value, you already know it, right? It is 1.26 times 10 to the power negative 6. And I1 is 80 amps. So you're going to put these things into your calculator, and then you're going to get the I2 in units of amps. I have 14.6 amps. Okay, so if I can send the current this much, I can keep the wire without falling down. Okay, that's the idea. If you have more current, current is lifting up. If you have less current, current wire is falling down. Okay, so now let's move into the number 5. Okay, so number 5, part A. Okay, let's make a space in here. That will be easier. Part A, B. We can come back to see later. So part A, right? So part A is saying a thin 10 centimeter long solenoid used for the past electromechanical switching has a total turns by and carry the current this much and calculate the field inside near the center. You know that the solenoid is something like this, right? So solenoid, when it carry the current, it will create the magnetic field inside the wire. That magnetic field depends on the direction of the current. That magnetic field is the one that we can calculate by using the formula for the solenoid. Solenoid, we have mu naught N and I. This N is number of turn per unit length, right? So now, according to the given informations, I will be able to write those into here. So mu naught, as we know, 1.26 times 10 to the negative 6. And N over L is given 400 uppercase N, and L is saying 10 centimeters long. That means 0.10 meters. Okay. And times I is 2 amps. So now this will give you the B, that will be 0.01 Tesla. Okay. It will be the center of the solenoid, right? So if you carry the current, you have to use your right hand direction of the thumb. If this is my top wire, then my magnetic field will be left. If it is my bottom wire, that will be magnetic field to the right. Right. According to that, you can calculate the direction. You can get the direction from your right hand. Okay, now part B is toroid. Toroid has the total turns in and current this month. Calculate the magnetic field radius 50 centimeter from the center. So you see that toroid is exactly similar to the solenoid, but important thing is this will combine to end into here, right? So now according to the current passing through the wire, depend on the distance, you have different magnetic field, right? So now if you need to find the magnetic field from 50 centimeter from the wire, then you need the distance to that. That is what the 50 centimeter means. You're going to find the magnetic field at this place, right? So now for toroid, the equation for that will be B equal mu naught N and I divide by the 2 pi and distance that where your point of interest from the center of the toroid. Okay, so now we have those information. Let's plug it. 1.26 times 10 to the negative 6, and number of turns is 800, and current is 2 amps, and divide by 2, and pi and r is 0.50 meters. Okay, after you plug that into calculator, your B will be 6.42 times 10 to the negative 4 Tesla. Okay, again direction, you need to use your right hand. For the wire, it can be clockwise or clockwise, counterclockwise, depend on the wire. Okay, so now C is the concept question that we try to get the understanding about how magnetic field behave if you have many wires on the square shape pattern. So now I have A, 1, 2, and 3, but what you see is those are current direction, right? And either into or out of the page. As you can see, in I label it as blue and out I label it as green. Rank them, comparing magnetic field at the center of the square. So we're going to calculate the magnetic field at the center of the square, not exactly the magnitude. First I need to check the direction. Okay, so we are watching this place. So now take your wire pieces. So you have outward current. So outward current will create the magnetic field at this place. Because of this wire, it will create the magnetic field on that direction. So now let's take this wire. This wire will create the magnetic field exactly same size, opposite direction. They're going to be cancel out each other, right? And then you're going to select the blue wire or the purple one that I have. Magnetic field is inward. It will create the magnetic field in this direction, this wire. And then you take the top one, use different color, this green, and top one also I have inward. Then your magnetic field will be exactly opposite direction, same size. So now magnetic field from all 4 wires in the first diagram will be 0. Okay, follow the same pattern for the other ones too, right? So now we going to move into the next one. Okay, next one you will see exactly same. I'm not going to do the colors because it will take time. So this is outward direction. If you watch in here, your magnetic field is this same as the red one on the top. And then this one will be again outward direction. It will create exactly same in this way. And then this +2 that I have on blue, will create the magnetic field exactly same direction, same size on top of that, and this will create the magnetic field exactly same size in this direction. That means there is net magnetic field creating into the left. Create the magnetic field left, not zero, right? So now you go to last one. Last one, since these are already done, you know that magnetic field will create this way and this will create this way. They're going to cancel out. Give me a second. Not that way. So this way, and this one will do the magnetic field this way. They will be exactly same. So now top two wires will create exactly opposite. You see that here? Dot, use your hand, okay? Dot outward, then we'll create the magnetic field this way, and this dot will create the magnetic field this way. So now this whole thing cancel out, they will be same, right? So now my ranking will be, you will see that my ranking greatest will be from the 2, right? 2, then your 1 and 3 are equal, and also they are equal to 0. Okay, so now last part, also I want you to see that you can understand how these things going to work with this kind of wire. So you can select the direction of the current. We'll say direction of the current is counterclockwise, that each piece you have the current the same direction, because you cannot have the loop current should be the same direction as always, right? But important thing is here your radius. So now this radius you have, right, will be according to question, read it. So that will be 3r, right? And then the radius of this one says 2r. Radius of this one says r. This each piece are arc shapes of the circle. So now let's go to the question. So now what will be the magnetic field at the center? Now I have pieces 1, 2, 3, and 4, right? So now these 4 pieces will create the magnetic field. It's very important that the piece I have here, this small piece and this small piece, what do you think? Those will not create any magnetic field because that is going through your point of interest. These will not create magnetic field. Okay, so only pieces I have here is number 1, number 2, and number 3. These 3 are pieces going to create the magnetic field. So now let's take the first one. So first one, I'm going to write B1. What direction it will create? Outward direction. It's going to use your thumb to the direction of the current, grab the wire at the center, it will be outward. So now magnetic field outward. We know that your magnetic field mu naught I for the arc shape, in this case pi divided by 4 pi and r, right? So now we're going to write it according to B1. That's common formula. Mu naught I over pi is, you see that it is half a circle. Now it is pi, right? And divide by 4 pi, and radius is now 3r. So let me simplify this. This will be equal to mu naught I divide by 12 and r, right? So now you're going to do exactly same thing for the next one. So now we're going to do for the second piece. Second piece, your current is this way. Again, we'll create the outward, right? So now that will be also equal to mu naught I. Now it is, you see that the angle that will make is 90 degrees. That means pi over 2 in here, right? Divide by 4 pi and 2r. So this will be simplified into mu naught I, pi going to be cancelled out, and 2, 4, and 16 r. So now third piece also create outward direction. So B3 will be equal to mu naught I. Now angle for the third piece also pi over 2 divided by 4 pi. Now radius will be just r. So now this will give you pi will cancel out mu naught I over 8 r, right? So now we have three pieces. Since all of them are in the same direction, we can write net B will be outward direction, and you can add them all, B1 plus B2 plus B3. Okay. So now mu naught and I and R are common. What you have it in first case 1 over 12 plus 1 over 16 plus 1 over 8. Okay. So that will give you total B. It did not ask you to calculate a number, it asked you to calculate by using just given variables, right? So 1 over 12 plus 1 over 16 plus 1 over 8 is 13 over 48. 13 over 48 times mu naught I over R. Okay. Direction is outward direction. Okay, so that's it for this worksheet.